Okay, and here I'm going to do part 2 of the answers to prepare you for the control constructs and methods retest. So I'm going to run through the solutions to the loop idioms test that y'all took on Friday. And again, I'm going to go through these pretty quickly. You can back it up, slow it down, whatever you need to do to understand. So we'll just go right through it. Sum, write a method that takes 2 arguments into numbers. How many numbers to add up, and numbers is the source of numbers. So, or I guess it doesn't really exactly say. Anyway, hopefully it's clear from the name. They're supposed to add up these numbers. How many numbers are we adding up? N of them. We're getting them from a numbers object. And so I can call this total, or let's just call it total. I could call it sum too. You can have variables and methods with the same name. And then we're just going to loop. This is a counting loop because we know I equals 0, I less than n, I plus plus. Our primordial loop, we're running n times because that's how many numbers we're supposed to draw. And then we just add numbers, next number, and we return the total. So that's how we add up numbers. Boom, there it is. Okay, public int average, actually public double should return the average of all these numbers, and since that average isn't necessarily going to be a whole number, then we should return a double as the problem says. So int n numbers. Now there's 2 ways to do this, and actually the good way is to just say return the sum of that many numbers cast to a double divided by n, right? Because that's what the average is. It's the sum of a bunch of numbers divided by however many numbers there are. We cast a double, so we do double math, and I believe that should do the trick. And I guess we'll just leave that, so when you can, you should write methods like that. Now, the next one is going to be a little trickier because average evens takes the same arguments, but we're only averaging the even numbers. So out of all the numbers we're going to draw from our numbers object, we're going to draw n numbers, and we're going to only pay attention to the even ones. So for that, we don't really have a good way to, we don't have a sum of just the even numbers, and we don't know how many there are. So this is actually a combo where we have to count and total sum of the numbers. So now we're going to write a primordial loop, I less than n, I plus plus, and now we have an if statement. If the number, so then we need to get a number. And so a lot of you did, and I pointed this out if you asked me during the test, or were stuck or something. So you could say numbers next number remainder 2 equals 0. So that means we just drew an even number, then add. Now the problem with this is that next number returns a different number every time. So we've checked one number, whether it's even, and then added a completely different number to our total. So what we need to do in cases like this is, we used n already, we'll call it num. If we need to use a value that we get from calling a method, and this also happens like with math.random, if you need to get a random number and then use it more than once, you got to save it in a variable. So save numbers.next number in a new int variable. If that num is even, then add that actual number, num, to our total, and also increment our count. So at the end of this loop, we will have totaled and counted all of the even numbers, and we can divide our total by our count, casting total to a double. If we had wanted to, we could have specified the total as a double, and then it would have just got infected earlier on. I don't know. I kind of prefer this, but I think it's fine either way. Okay. average n evens. What's different here? Same arguments, takes an int and a numbers, but this time we're going to average the first n even numbers. So this is an example of a while loop. In fact, let's just copy this. Well, it's going to be a little bit, I don't know how much we're going to keep, but anyway. N evens, the main difference is, actually, I'm going to just write it from scratch. It'll be more clear, I think. Okay, so the basic idea here is we're going to write a while loop, and we're going to count how many things we've gotten less than n. So that means we need to add a count variable that we're going to increment in the loop when we find an even number. So similar as to before, we're going to pull a number out of next numbers, and if that num is even, then we're going to, so probably same deal for, so if it is actually an even number, we add it to our total, and we increment our count. Now this time, we're not incrementing the count because we need to know at the end, because when we get to the end, the count is just going to be n. Right? This loop will end when count, after the last time count gets incremented and count is now the same as n. At that point, we have drawn n even numbers from our source of numbers, and now we can return the same thing. And so we can use either count here or n. Really doesn't matter one way or the other. Let's just use that. Okay. Any bigger than. We are now on to the sort of Boolean patterns, where the point is we're going to be given all right, so this should take 3 arguments: an int specifying how many numbers to draw, an int specifying the limit and the numbers, the source of numbers, and we're going to return true if any of the numbers that we draw in the course of drawing how many we were told. So let's call that n. We're going to draw n numbers, check if any of them are bigger than our limit, and numbers, as always, is our source of numbers. So this one, we don't need any variables to accumulate because we're going to either return true or false. So we just jump right into it. I0, I less than n, I plus plus. If numbers next number greater than limit, return true. So we found one. If this is true, we've found a number that's bigger than our limit, and we immediately return true. And if we get all the way through that loop, we've checked all n numbers, then none of them were bigger, so we return false. All right. All smaller than. This is going to be another Boolean, but it's going to be slightly different deal. Public Boolean all smaller than. Also takes 3 arguments: number of numbers, a limit, and the numbers object. So we can just grab this. And this time, so we're still also drawing I less than n, I plus plus. If numbers next number less than limit, or sorry, what are we doing here? All smaller than. So if we see one that is smaller, that doesn't really tell us. It just tells us that number's okay. So actually, if we see one that's greater than or equal to the limit, that's something that's not less. So we need to return false. Only if we get through the end can we safely return true. Public. So n numbers. If we see a counterexample, something that's greater than or equal to the limit, then we return false. That means they're not all smaller. And if we get through the end, success, we return true. So note in both of these, I used numbers.nextNumber directly in the if statement because I didn't need to do anything with the number after I checked it. I just needed to know whether it was bigger. And so in this case, it's kind of silly because these numbers are just coming and we're not really doing anything with it. But in other contexts, like if you had a big list of numbers and you wanted to know if any of them were bigger, you don't actually care which number is bigger. Okay. Now we move actually on to, as I just said, that first bigger than. So this is a finding method. We're going to draw from our numbers object the first one that is bigger than some limit. So it's going to return a int. This one is taking a limit and a number of numbers, and we are just going to go forever, potentially. Right? It doesn't say how many to check. It just means keeps checking, find the first one that's bigger. So depending on how these numbers are generated and what the limit was, conceivably, like for instance, if the limit was max integer, it would never be true and this loop would go forever. But we're assuming that the caller is not going to call us with nonsense like that. And so we're going to loop forever while true if numbers, but this time, okay, so now this is one where we need to hold on to the number. So let's get the numbers next number. If num greater than limit, found one, return num. And this should compile, I believe. Great, right? And so this, some of you might wonder why, who ran into problems where like missing return statement. The reason Java is okay with this is because it will never get out of this loop except by returning. So there's no way to get to here and then not know what to return, because the only way out of this loop, because it's while true, is to return num. Just for grins, let's check. If we say Boolean, let's not bother with that. So while true, get the number. If the number's bigger, return it. And otherwise, just keep looping forever. So, and I nicely always called it with things where it would find one eventually. Okay, index of first bigger than. This one's a little different. Also returns an int, but not because it's the value, but because it's the position as we, if we're counting where we are as we draw these numbers, we're going to return the position where we found the first number that was bigger. And so this one, I think, takes 3. This was the one that period 1, it was not described correctly, and I had to tell you in person, but now it's just correct. So it takes 3 numbers, a number of the numbers to draw, which we've been calling n, the limit, and a numbers object. So it's a lot like some earlier methods. All right, and so this time it is a counting loop. We're only going to draw n numbers, and there's a possibility that if we get through all n numbers and we haven't found one that's bigger, then we're going to return -1. So I 0, I less than n, I plus plus. And now we can actually go back to, we don't actually care what the number is, but if the number that we draw is greater than the limit, then we want to return where we were when we found it, which was at I. So if the very first number was greater than the limit, we'd return 0. If it was the next number, we'd return 1, and so on. So whenever you're finding an index, you're probably going to return the loop variable. You don't actually, you're going to use this other value that in this case that we're drawing from numbers, but then we return the loop variable. And if we get to the end of the loop, this is the place where the compiler would complain. I'll even show you. So if I try and compile this, I'm going to get an error over here, missing return statement at line 89, because at line 89, it's like, hey, this method is ending and you haven't told me what to return. So that's where we put our distinguished value of -1 that the problem specified, and as a general what we return for index when we're looking for an index. And now that one's done. All right, count odds. This one should have been a gimme, mostly, since I gave you the count evens boot up. count odds, and what is this, int? Right, so it's taking a number of numbers and source, and it's a counting function or method. So we're initialize our count, we write our loop, I equals 0, I less than n, I plus plus. If, let's see, next numbers, next number, greater 2. So if we were doing even, so this is going to be completely backwards. But so this is our count evens from the other day. And so this was really just a slight trick to see how, and you might have just gotten lucky. So one way to, you might think is like, oh, well, if it's not, remainder 2 is not 0, then it's going to be 1. And that would work if all the numbers were positive. But as it turns out, remainder 2, if the number that you're taking, this side, is negative, you get -1. So the right way to check, and I've said this in class, is that it's not equal to 0. So check for even, check that remainder 2 is 0, check for odd, check that the remainder is not 0, because that will cover both the 1 and -1 cases. And then finally, the sum of products is another sum. It's going to take 3 arguments, int m, and our friend numbers. And the key in this problem description is that we're going to total up all of the n times m products, meaning we're doing something n times and something m times, and we're getting all of like n by m different products. So this was the problem that was calling for a nested loop, basically, was the point of this problem. So we're going to write a regular loop that's going to loop n times. And for each of those n times, we can just call this num1, numbers, next number. And then, what does it say? Draw n numbers, so that's what we're doing in the outer loop. And for each of these numbers, meaning each time through the loop, multiply it by each of m numbers drawn from the numbers object. So that means we got to put in here another loop. J is the traditional next sort of index variable name. Make sure that you write j++ here, not I++, because otherwise I get an infinite loop. So I 0, I less than n, I++, j 0, j++. So just another primordial loop, just with a different variable name. And what is this? This is a summing problem, so we need to have a total that we're going to accumulate into. Total plus equals num1 times numbers next number. We could stick that in a variable, but since we're only using it in this one place. So num1 is the number that we picked from n different times. We're going to get a different number here. And then for each of those numbers, we're going to get, m, I almost messed that up, m different numbers, multiply it by num1, add that to our total. And then when we're done, the total is holding the value we want. Hit reformat on that. All I did was move my brace. And that is all green. Okay, so like I said, you can rewatch this, you can slow it down, you can speed it up, whatever is going to help you absorb it, but hopefully this was helpful for you.